Hello everybody. In this video lesson I'm going to talk a little bit more about naming compounds. We started with binary ionic compounds in the last video. In this video I'm going to kind of finish up the binary ionic compounds with what are known as the multiple charged ions. So just to recap really quick, sodium chloride is a compound. These are the elements. We're focusing on naming and formula writing of the compounds at this point. We already talked about naming ions, or I'm sorry, naming the elements. Now we're talking about naming compounds. We're not talking about how they form, we're just talking about naming and writing these compounds. And we're strictly staying with ionic compounds. And keep in mind that when you're dealing with ionic compounds, they have to be neutral. So they're going to remain neutral. Alright, so we have to keep the charges balanced. So we have a cation named sodium ion. Okay, so we have a sodium ion. We have a chloride ion. So we have a positive charge and a minus charge. These charges come together to create a neutral compound, sodium chloride. So the individual name of the ion is sodium ion. We don't change anything really for that, but we change the end of the anion to IDE. Then when we write the compound, we just join those two together to make the formula. So we would say sodium chloride is NaCl, sodium chloride. So pay attention to that IDE ending. And that actually brings up an interesting thing I just want to show you real quick. If you're dealing with the ions, okay, naming is very important. What I mean by that is if I say sulfur, what you should write is S. No charge, no compound, it's elemental sulfur. If I say sulfide, that is now an ion. So therefore that will now have a 2- charge. Okay? If I have sulfate, that should clue you in that this is a polyatomic ion. So you should hopefully start memorizing those polyatomic ions. If you haven't done so, I would strongly recommend you do that. So sulfate is SO4 2-. Sulfite is SO3 2-. So you can see the endings of each of these words really has a huge impact on what I'm writing, because these are very different things. Now, this is sulfur, it's a yellow solid. This is an ion, okay, and it tends to make, when it bonds with things, it tends to make them substance black. Sulfates tend to be your acids as well as your sulfites. So when we have these different names with the different endings, it's very important you pay attention, because if I say IDE, you should be looking up sulfur with a 2-. Sulfur is just the elemental substance. So think about this, pay attention to this, and watch for it as we start doing some other naming and formula writing. Alright, hopefully you remember the periodic table, right? You're going to have these charged ions here on your periodic table. You should already have these written down and you should be familiar with them. So when we start writing our ion, we're talking about when they become ions, it's going to form a +1. When it forms an ion, it forms a +2. It forms an ion for oxygen, 2-. So if I go back to naming and formula writing like I did last time, kind of ended on this in the last video. Alright, let's get rid of this. Okay, so let's say that I have, let's get black here. Let's say barium. Now let's go with bromide. Okay, all I'm going to do is if I give you the name, I want you to write the formula. Now barium is on the periodic table and it's here. So it has a fixed charge. It's going to be one of my fixed single charged compounds, right? It's going to fall into this category. That's what we did last time. Let's get rid of this. So all I would do is I would write barium with its charge from the periodic table. In this case, barium 2+, because it's an alkaline earth metal. Bromide is a halogen, Br-1. So therefore I put them together as Br2. Why the 2? Because I have to balance the charges. I have a +2 here. I need a -2 on the other side. So therefore I need a second bromide to balance out the +2. So both of these have to attract to the barium. Okay, and that's where I get BaBr2. That's why the 2 down here tells you how many ions are in the compound. Remember, this is a neutral compound, so this +2 has to be balanced with the negative charge. One more. Let's take a look at aluminum oxide. Aluminum has a 3 plus charge. Again, I look it up on the periodic table. Oxide, it's not oxygen, but oxide has a 2 minus charge. Now again, I have to balance the charges here. Now it's a little bit tricky because I got a 3 plus and a 2 plus. So what you should look for is a least common multiple between the two. Hopefully you all know that that's 6. All right, so my least common multiple is a 6. So therefore I got to get a 6 plus charge over here. Al 3 plus. It's going to give me minus 4. If I do one more, it's going to be minus 6. Over here I've got plus 6 for my charge. Therefore, how many aluminums do I need? 2. How many oxygens do I need? 3. And there's my formula writing for ionic compounds. Okay. One little trick here to watch for: if I'm balancing aluminum 3 plus and oxygen 2 minus, what I could do is I could actually use this and just crisscross them. This is a little shortcut, so be careful with shortcuts because this will not always work, but it does work for a lot of them. Okay, so it's a good little shortcut to remember. But remember, the real idea is that you're balancing the charges. Charges have to be balanced. This has to be neutral. Okay, so let's look at something else here. Let's look at, what if I gave you the name? No, I'm sorry, if I gave you the formula. Let's say that the formula is CaF2. Alright, so it would be calcium fluoride. That's it. That's all you do. Just name the anion and the cation. That's it. So name your cation, name your anion. Okay? Alright, so things can get a little tricky though, so let's take a look at what happens when we get to something else here. Okay, let's take a look at, if I gave you the name iron chloride. Okay, remember what I would tell you to do is you write the symbol, Fe, then write the symbol, Cl, and what I would do is I get on my periodic table and I'd look up iron. Uh-oh, there's no charge here. That's a problem. Chloride, still -1, so that's not a problem. It's this iron, because I didn't tell you what the charges were for these. Your transition elements, there aren't any charges except for zinc, cadmium, and silver. Those are the only ones that really still have charges on them. So what do? How do I fix this problem? Well, the problem is I kind of cheated here a little bit. This is not the right way to write the formula for iron chloride. What I should have done is I should have said iron 2 chloride. I needed to use what's called a stock number. The stock number is a number that we use to indicate the number of charge on the cation. So this is what's called a stock number. All right, and the stock number tells you the charge on that ion. So therefore what I would do is I would write Fe for iron, and then I would write 2 plus for the charge. So you don't have to look it up. I have to tell you it. What's hard is for you to go backwards, and I'll show you that in just a second. And then chloride would just be Cl minus, and we do just like we did before, FeCl2. So we would just balance the charges, and again, stock number, and this is what students get confused all the time. Stock number tells you the charge on the cation, not the anion. It does not tell you, listen, it does not tell you how many ions. This does not mean you write Fe2Cl. It does not tell you, no, it does not tell, I'm going to see so many of you do that. It does not tell you how many. It tells you the charge on the ion. Okay, so let's take a look at another one. Let's see that I have cobalt 3 sulfide. Alright, so I write cobalt. What does a 3 tell me? It tells me the charge on the ion. Sulfide is 2 minus because it's sulfide. So therefore when I balance these I can do that little crisscross method and I would end up with cobalt with a 2, my sulfur with a 3. So there is my cobalt sulfide. And that's it. So I have to give you the stock numbers. Now, what happens if we go backwards though? What happens if I'm going to name? And this is where students have the biggest difficulties with this, is in the naming with these things. So let's go ahead and do that. Let's look at naming compounds with multiple charges. So here we go. Let's say that we have NiCl2. and let's put in here sulfur. Okay, so I've got NiS. So we know it's nickel, so I'm going to name it nickel. What I would start doing from now on is always leave yourself a little bit of space. Sulfide. Okay, and a lot of people are just going to leave it nickel sulfide, but what you have to do is you have to realize that nickel is a transition metal. Right? Nickel is right here, it's a transition metal, so it's going to have a stock number. Little rule of thumb is that most transition metals need a stock number. Most transition elements or metals need stock numbers. Now I'm saying most because there are some that don't. The ones that don't need a stock number are the ones that you've got listed down here at the bottom. Zinc, cadmium, and silver. No stock number for these three here. They do not use a stock number, but any other element that you use in here would require a stock number. So that's how you know. All right. The way you know is that if it's a transition metal and it's not silver, zinc, or cadmium, which have no stock numbers, you are going to have to put a stock number in. So now everybody freaks out and goes, oh my gosh, well what stock number do I use? Well, you should know what sulfur is, right? Sulfur is a 2-, so therefore your nickel must be a 2+, right? Because you have to balance it. So it would be nickel 2 sulfide. So I would say nickel 2 sulfide. A lot of people miss those stock numbers, but be careful. So the way you do this, to make sure you get the stock number, is if I give you the compound and I say it's something like copper, and we put oxygen here. Alright, so if I'm going to name this, I'm going to name it copper. I'm going to leave myself a little bit of space and go oxide. Then I ask myself, is it a transition metal? Is copper a transition metal? I look on the periodic table, and oh, yes it is. It's very close to zinc, silver, and cadmium, but it is not one of those three. So it is a transition metal, but it is not silver, zinc, and cadmium. They have no stock number, so only three. So therefore, I have to have a stock number. So the question is, what's the stock number going to be? Well, if I have oxygen has a -2 charge, that copper has to be 2+. So therefore, what is the stock number? The charge of the ion. The charge of the ion. The charge of the ion. Last one I'm going to do is Cu2O. Students get these two mixed up all the time. We already know copper is a transition metal and that it's going to require a stock number. Oxide over here. Well, if my oxygen is 2-, what does a 2 down here tell us? It tells us how many coppers, right? So I need 2 coppers here. So therefore, if we think about this, this needs to be balanced. So we need to have a 2+ here to balance out my oxygen. So if I distribute the charges, what will each of those coppers have for charge? Hopefully you know, +1. So my charge on each of those coppers is a +1. Again, it tells me the charge of my ion. That's the function of the stock number. Alright, so we'll practice this in class. I know it's very confusing. A lot of students have trouble with this in the beginning, but that's why I start with it, because I know there's a lot of questions on this. So, next video lesson, I'll incorporate polyatomic ions, so make sure you get those memorized. Later.